In this video, we'll be looking at one of these questions, which was part of another video that I've uploaded, but I've done it wrong there. So I didn't even notice, and thank you to the person who noticed this. So I'll be doing this one again just to rectify that error. And by the way, this is a slightly more difficult question rather than the average kinematics question that you have. So let's first look at this. A sprinter takes a time of 11 seconds to run a 100-meter race. She first accelerates uniformly from rest, reaching a speed of 10 meters per second. She then runs at a constant speed of 10 meters per second until the finish line. What is the uniform acceleration of the sprinter for the first part of the race? So there, as you can see, there are really two stages to this journey. So she takes a total time of 11 seconds to cover a total distance of 100 meters. First, she accelerates uniformly from an initial speed of 0 to 10, and then she runs at a constant speed of 10 until the finish line. So if you think about what the finish line is, the finish line would basically be when the total distance covered is 100 meters, and the time corresponding to that distance would be 11 seconds. Now, just because I find it easier to visualize this, that's why I'm going to make a graph. I know most of you guys rather steer clear of graphs, but trust me, in this one, it is going to simplify this problem. So let's make a small graph here. So this is a normal simple time speed time graph. So let's make this. So on the y-axis we have speed here, and on the x-axis we have time. So if I think about this graph, then I know that it's initially going to be a uniform acceleration. So this means it's going to be a straight line, and this is going to be so that it reaches a speed of 10 meters per second, right? So this speed is 10 meters per second, but the time corresponding to this I do not know right now. And then we know that it covers distance at a constant speed of 10 meters per second until the finish line. But I do know what this final time is, because this is the time of the journey, which is 11 seconds, right? Now, I also know that because this is a speed time graph, the gradient is acceleration, which is really what I need. And the area under this entire graph is going to be distance. And I know that the distance is going to be 100. So what I can now use is, let's say if I call this time some time t, I can figure out t, basically because I know that all of this area under the graph is 100. And then once I have t, then finding the acceleration is very easy. So let's go ahead and do that. So all of this area is 100. So if I look at this, you can also treat it as a trapezium, or if you find it more convenient, you can break it into a triangle and a rectangle. Trapezium is obviously what I'll be going for. It just gets the job done in one go. So this is one parallel side, this is another parallel side, and this is the height, the distance between the parallel sides. So area is distance, which in this case is half into height into sum of parallel sides, a plus b. So one parallel side is this 11, the other parallel side is this. So if this is t, this is 11, so this is going to be 11 minus t. And the height is 10, so half into 10 into 11 plus 11 minus t, and this should equal 100. This is what I know for a fact because that's the distance. So this becomes 5 times 11 plus 11 minus t, which is 22 minus t. Now here on out, this is just algebra. 100 over 5 is 20, so 22 minus t equals to 20. So t is very obviously 2. So now I know that this time t is 2 seconds. So the acceleration is just going to be the gradient of this part, or you can use v minus u over t. So 10 minus 0 over the time 2. It's very obvious, but I'm still writing this out. A would be 10 minus 0 over 2, which is obviously going to be 5 meters per second square. Hence the answer here is going to be D. So I know that you guys usually stay clear of graphs, but this is one of those cases where if you do make the graph, then things just become very obvious. Otherwise, if you chose not to make the graph, then what you would have to do is apply equations of motion separately to both of these parts, which I feel is definitely more complicated than making a simple graph. So that's this solution. Hope this helps.